Hello, ladies and gentlemen. Welcome back to this breakout session with the topic of research focus. When we talk about innovations, trends, future resources, we automatically need to address the topic of research. This is where the foundations are laid, but this is also where new networks are created, which then, in return, boost the development of additive manufacturing. We have invited 6 top international experts from research for you, and we want to talk to them about the topics they are currently working on, what their challenges are that they're currently facing, what can be optimized in international cooperation, and what is currently needed. Please welcome with me here in the panel on stage, to the left, Professor Katrin Wudy, Technical University of Munich, Professor for Laser-Based Additive Manufacturing. Hello, Katrin. Good to have you here again. Then we have Professor Markus Bambach. Hello. From the ETH Zürich, Professor for Advanced Manufacturing. And also on stage, Dr. Christian Leinenbach from the EMPA, Head Advanced Processing and Additive Manufacturing of Metals. Then, of course, we are not ready yet. We have guests virtually connected with us. So, from the Shanghai Jiao Tong University, Associate Professor of Materials Science, Professor Lianghua Xiong. Hi, Lianghua. Good to see you. And we have Professor Anping, also from the Shanghai Jiao Tong University, Professor of Materials Science. And then last but not least, heartily and a warm welcome to Professor John Hart, Massachusetts Institute of Technology, Professor of Mechanical Engineering. John, good to have you back again. Hello, how are you doing? Cool. Katrin, it's good to have you on board again. What is currently in your research pipeline, and how much are you actually affected by the geopolitical events?
Yeah, so thanks, first of all, for the invite again. So actually, the topics we are working on at the Technical University of Munich are quite similar to the topics which are addressed from industry today. So there are 3 different streams. One stream is productivity of powder bed fusion. Another stream is to bring new materials into the market. And the third topic is actually applications, to develop new applications. And to give you an idea on the glance, what the specific topics are. For example, in the field of productivity, we are developing together with the industry, with the US and Oerlikon, for example, a new kind of beam shaping technology to increase the productivity in powder bed fusion. We would like to increase the productivity on a level of to get 7 times faster compared to the traditional process. And if you have a look on development of new materials and laser-based processing, this is driven by trial and error. And I always wondered why this is driven by trial and error. Everyone is doing the same experiments, and it took weeks to get process parameters with parts with a high density, and therefore we develop a high throughput experimental setup to develop process parameters for novel materials in just a few hours instead of weeks. And the other topic, I always say it's some kind of my hobby, to bring additive manufacturing into novel applications. One application is, for example, the production of polymer-based solid-state batteries out of an additive manufacturing technology. So actually, we are covering all the topics which were addressed from the industry today.
And how you are affected right now with the let's say, global situation we're facing now? Is that something you feel and see in your work, or?
Yeah, of course, we see it in the different areas. Have a look on materials, right? So the supply chains also for materials are difficult. So we see it also on our daily basis, but nevertheless, we strongly work together also with other researchers all over the globe. So.
That brings me to Markus. Markus, we discussed this in advance about international cooperation. What are you currently working on, and to what extent are you internationally collected, because this is something we want to explore in this panel discussion, and how strong is the desire on your side of the international research markets to network more closely, because we discussed that up front.
Yeah, so thank you for having me here, and thanks for the question. We are working on various topics in additive manufacturing, for example, multi-material printing, where we work with Belgium, simulation, where we try and share our codes with Aachen, for example, but also internationally. We had a student who joined John's lab in the past, so I'm also loosely connected to the US, I would say. So I think we have a great network and we have a lot of opportunities to work together. What we do not have is funding opportunities. So mostly then it's outgoing students or incoming students that we host. And I would, if I could make a wish, I would wish for more opportunities for funded international projects and for speed. So sometimes I feel like I have a network, let's say in Germany or abroad, and I could solve a problem that a company faces, but there's no funding line, and if there is one, it takes ages to get the funding through, and until we have the funding, the problem does no longer exist, to be honest.
Very good remark. Funding brings me a little bit to you, Christian. So you studied and worked in Germany and Sweden, and now you're at the EMPA. What are your current topics, and how do funding systems in Switzerland, because Markus just addressed it, differ from those in other regions?
Yeah, concerning the research, I'm working for a material science and research institution. So materials is actually one of the biggest topics there. We develop new materials for additive manufacturing, but we do additive manufacturing of new materials. For example, novel high-temperature alloys, high-entropy alloys as well. And over the last years, functional materials such as shape memory alloys have been in the focus of our research, and making components, multifunctional components from them. Another research topic is the in situ and real-time process monitoring, defect detection. And the third big topic, which is currently emerging, is powder degradation, powder recycling, upcycling of scrap material, because we see an increasing interest on the industry side there. And there we have recently started to really do some investments and ramp up the research.
Very good.
Concerning the funding institution, well, I've been in Switzerland for the longest time now, more than 15 years, so I'm most familiar with that system. But compared to Germany, Sweden, or any others, on the national level, I think all the countries, they work rather similar. I cannot complain about a lack of support in Switzerland. However, in Switzerland, we're facing some problems now with the access to, for example, the Horizon program because of some political decisions. We have been sidelined for the moment. We can participate, but it has become more problematic, and we are not allowed to coordinate projects. So for us scientists, this is really a big loss, and it hinders making international contacts.
Very good. Let's make a trip over the ocean to Lianghua or Anping. What are your focus area in additive manufacturing? And I mean, we addressed already a little bit the international networking. To what extent does international networking has an impact on your work in China?
Thank you. Thank you for having us here. Basically, we focused on the data-driven novel materials design for metal additive manufacturing. First of all, we develop process monitoring and control expertise, such as high-speed synchrotron X-ray imaging and diffraction capabilities to in situ investigate the laser printing process, discover the mechanisms of melt pool and phase transformation dynamics, and to stimulate the process optimization and quality control of 3D printed parts without trial and error. Meanwhile, we apply experimental inputs to guide multi-physics simulation and modeling to precisely determine defects dynamics and pinpoint the temperature, melt flow, and the subsequent residual stress. Therefore, through combining experiment and simulation, we have obtained a large set of data on AM process from atomic phase structure scale, micron melt pool scale to macro mechanical property scale. Then we feed this data to machine learning models to accelerate novel materials specifically for AM applications. Fundamentally, we believe that international networking has a significant and positive impact on our research. Professor Tong and I both did postdoctoral research in Missouri University of Science and Technology in the United States, and we have continued collaboration with for many years U.S. partners from Missouri SMT, Argonne, and Oak Ridge National Labs, and the University of Wisconsin-Madison, and other affiliated collaborators. We just concluded a collaborative program with Israel aerospace industries focused on developing AM methodologies and redesign spare parts for aerospace structures. We also maintain intensive cooperation with the National University of Singapore and KU Leuven via exchange students, seminars, conference organization, and publication. So we welcome international collaboration with open arms. Thank you.
Great, thank you so much. So I've heard already some similarities, at least in the research focus. John, we just heard there's an exchange of students there between you and Markus' team. That's what I heard. So you work already closely with international partners. What topics can we expect from you at MIT in the near future? And do you see a specific focus depending on the region in terms of research?
Thank you, and hello, everyone. One of our focus areas is using advanced instrumentation to monitor AM processes, particularly metal AM via laser powder bed fusion and binder jetting. And the goal is to enable a clear correlation of precision experiments to predictive models of the process, as well as to follow the variation. Right? So we know that spreading the powder layer is a very important initial step in the AM process, but for instance, there has not been a lot of quantitative study of how powder layer quality relates to the statistical quality of a printed part and the probability of defects arising from deterministic sources and non-deterministic sources. So we have worked on that recently, and we're carrying forward our understanding of powder spreading now to the printing process itself, and developing in situ measurement techniques that can correlate to post-print measurement, as well as sensing information collected in real time during the process. I mention that because the work has not only grown up in our group at MIT, but in collaboration with the Lab for Numerical Mechanics at TU Munich and good friends at Politecnico Milano in Italy. So in fact, it is an international network where we're seeing how different competencies, both on the experiment side and on the computation side, can come together to build a holistic picture. And I very much agree with Markus' comment about funding. It would be great to have more international funding opportunities. But that said, having students exchange and work together has really been the glue. Those student exchanges, and fortunately MIT has a great program to promote that, have gotten a very exciting collaboration started where we can each follow our own research lines and then identify how we come together and define the joint goals and publish together as well.
Very good. You mentioned data. Katrin, let's close the loop. You have now heard several exciting projects of the colleagues, and I know you collaborate already a little bit, but where would be one topic where you say, I'm directly stepping in and try to foster a little bit more collaboration here?
Yeah, actually, I'm always impressed by my US colleagues because they recognized quite soon that binder chatting is a hot topic in emergent field. John mentioned it before, and this is something actually we in Germany here are a little bit lacking. I think today there was not really a talk on binder chatting technology. This shows it quite impressively. That's why I think this is a topic for a collaboration in this field, for example. Yeah.
John, another question for you. Coming back to the data, I mean, you say there's a student exchange and there were joint projects here. I mean, as I wish that we are going faster in development, it would be great to share this data. Is that something that is happening? So is there kind of an open database regarding data, like real-time observing of the process or results of experience? Is there something like this existing?
Yeah, it's a great question. I think we need to work more in that area, and also industry and academia maybe get together and understand how more entities can share data in common formats and what are the standards for interoperability, also along the process chain. I'll add two more things. One is we've started within the US collaborating with a group at the University of Illinois that is developing with us a method for automated image analysis of cross-sections from metal AM. And there's also a strong effort from NIST, the National Standards Bureau in the US, to create benchmark tests. And I think that is one point where more data sharing can be established. Second, an open question is, as more data is gathered, right, data enables understanding. So how do we balance sharing of data with the ability of companies in particular to advance their proprietary understanding? And I'm trying to learn about the data science techniques that enable, say, computation on a data set and learning from that data set without revealing the basic elements of the data set. So techniques such as federated learning have become interesting to us lately.
Very good. Quick side remark for the audience. If you want to ask questions, now would be a perfect moment because I have a look on my iPad to see whether current questions occur. In the meantime, let me ask, talking about data, it always brings me to the thought of competition, don't get me wrong, but is there a certain kind of competition, Christian, between you and the other universities?
Well, not really a competition, or if there is a competition, then in a very positive sense. But there is really a lot of exchange also between us and different universities in the United States and also in Europe. So among the scientists, I think we are rather open-minded in that regard. Of course, industry, it's clear, cannot be as open-minded as we are or not give all the data that is required. But here, I would not say that this is a big competition.
But you mentioned industry, Markus. Katrin says they are working closely together with industry. Are sometimes the companies that are sometimes funding or supporting these research projects saying, sorry, excuse me, please do not exchange data with another region because it might end up that the data is being received by a competitor? Is that something that takes place or not an issue at all?
Of course. You have to sign some NDA up front, and then, of course, in the actual project contracts, IP is always protected. So I don't know any case where we would give data from industrial partner to other partners. Regarding competition, I think we do compete in academia. We want to be the first to publish new results, that's clear. But we should learn how to share data and how to make it possible for others to access the data.
Yeah. So, Lianghua, how do you see that? Is that an issue from your side, or would you say you are open to share everything you have with the colleagues over here and in the US?
Not really, actually. Since the AM technology is really complicated, and then we develop many in situ and ex situ methodologies to understand the laser printing process in a better understanding. For example, previously we developed the in situ capabilities at Argonne National Lab. like the synchrotron high-speed X-ray imaging and diffraction capabilities, but we open it up to global researchers, so everyone can access to the high-speed X-ray imaging and diffraction methodology at Argonne, and to perform the in-situ experiment of your own material systems. So this kind of like we want to share this kind of methodologies and to try to collaborate with more researchers sharing the same research interests. To this end, I think we can move the AM applications a step forward. I think we can collaborate to a deeper extent, and work more closely. Yeah.
So I think we made crystal clear, we defined the clear wish of more collaboration. Christian, you have another remark?
Yeah, just a remark. I'm sometimes surprised to see when I go to conferences that several ideas are just in the air and several teams are really starting to work on that and find own ideas. And as Markus said, yeah, everyone wants to be the first one to come up with great and new ideas. But in my experience, if we come together, there's an open exchange and we discuss openly about the things that work, the things that don't work. And in my opinion, this is how it should be in science, because only in that way we can advance the science.
Especially when we consider that your research focus is sometimes complementary, so you can assist each other in reaching your results. We have two questions from the audience. First one, I give it openly to all of you. What is, according to your experience, the most complete way to validate additive manufacturing parts, particularly for critical application like aerospace, medical, etc.? Who wants to answer the question for validation?
What does validate mean?
I think it's about quality and...
I mean, I think it's an unsolved problem generally, and we need to understand that there needs to be a paradigm shift from fully testing parts to printing a part, having a set of data, and someone is able to sign then and say, okay, we can, based on this data set, we can release this part and it can be really used on an aircraft or so.
Very good, very good. Perfect answer. So, Katrin, a question for you. Do you see AM energy storage, for example, batteries, becoming cost competitive within the next 10 years? The low cost of lithium-ion seems to make traction in this area quite challenging.
Yeah, actually, the topic I've mentioned on the polymer-based solid-state batteries, these applications are on a really low TRL level at the moment. But from my point of view, additive manufacturing can make there a really great contribution if we also work on the processes itself, like qualifying the processes and bring novel materials into the market and increase the productivity. And then, from my point of view, we can compare with other conventional manufacturing techniques. If you have a look on battery production, you have many steps in battery production. And if you can have only one production process to produce your, for example, separator element, then this would be an advantage compared to the conventional way.
Very good answer. Thank you for that. Another question for everyone again. Much of AM development happens in areas with a lot of resources, for example, national defense. This naturally limits collaboration, thereby limiting growth. Do you see any creative workarounds to this paradox? John, probably a question for you.
Yeah, it's a hard problem to solve when there's confidentiality restrictions, but I'll say more open education and sharing of benchmark case studies, what works, what doesn't work, and the details of the journey needed to bring an application to fruition, I think can help break down those barriers. Also, communities of practice within certain industries and across industries can be very valuable. So I like what ASTM is doing and bringing focus groups together and workshops in different areas, as well as bridging the experiment side with the data side, as we described earlier, and making sure when data is shared that it's fully labeled, because it's one thing to share the data, but it's another thing to understand the ingredients that went into creating that data. Therefore, it can be interpreted and adapted to other scenarios.
Very good answer.
Yeah, and maybe to add something there, so we talked about open science and open databases before, and I think they can be really helpful. And these open science principle is on a high level pushed from the European Union, for example, in the new Horizon programs. So this is something I think which is important for the future, to have open data sets, to share data with other researchers and discuss the data. Because at the end, from my point of view, we are not really competing, but we are working, all of us, for the same goal and aim to understand the processes and so on. So we are all some kind of AM nerds who are working on the same goal, and that's why sharing data in an open science principle is really a high value.
Especially, I mean, we discussed a lot during the 2 days about solutions that AM's delivering to current issues or challenges we have in the world. So this alone should be a motivation in order to share more data. So here's one question probably for you, Christian. How can we accelerate the development, industrial qualification and usage of new alloys?
Again?
How can we accelerate the development and industrial qualification and usage of new alloys?
Well, okay, acceleration, the development, there are approaches such as, well, big data approaches, including machine learning, combined with high throughput alloy design using multi-nozzle deposition methods or multi-alloy deposition methods, really for fast and rapid screening. So in this way, we can identify alloys. However, this does not solve the problem with the, well, acceleration to, again, to validate the material, to really see whether they can be applied for certain industrial purposes. So this we cannot do without the end users, because they have to tell us what exactly these alloys should be used for, and only then we can come up with a test program also for that.
So it's kind of, I don't know how it's called in English, the egg thing, where what is first, correct, basically. So you need the application or the use case in order to start the investigation.
Yeah, we are often approached also by companies, but so they say we want that, but we would like to have at least 10 years of experience with the alloy, which we cannot deliver. Of course, this is an exaggerated expression, but this is a bit what is expected. So it's difficult to come up. We as the researchers, we cannot do research beforehand without knowing what the goals should be. So there we have to do that together with industrial partners.
Let us drive a little bit more the topic of funding. I know it's sometimes frustrating, but I still want to know, is there an exchange with politics from your side, from research side, to show the need? Because the one thing is to acquire for funding, the other thing is to explain the counterpart that they should invest in you and not in other projects. Is there an active exchange here on the European side with politics about that?
So we've heard it before. I think the B2B collaboration to other researchers is really good and fruitful, but what is really needed is to reach out to politics and establish, for example, funding schemes together with other countries. There's one nice example. We had a talk to Swedish colleagues several weeks ago. So Swedish professors together with German professors all over, so from all over Germany and Sweden. And actually there is only one call between Sweden and Germany. But in Sweden, for example, material science is a huge topic. And in Germany, we are really good in laser-based manufacturing technologies. And in this field, we would like to establish a new program, for example, and reach out there to politics. I think it's important, but it depends, right?
Okay. John, what about the US? We haven't talked about the US and the funding topic so much. How difficult is it for you to get the funding? Is it more focused on private industry supporting you, or do you have like a similar funding system like we have here?
Our funding is a mix of sources from industry and from the federal government and from some private foundations, some donors, and it's good to have a healthy mix, because you have support that's more early stage basic research and support that's more late stage sort of translational research. The number one thing I find is it's important to articulate the value proposition, and Additive is a very busy and in a good way, a competitive field, meaning there's a lot of ideas competing for limited resources. So bringing collaborations together so you can do more by putting complementary pieces in a team, but also when advocating for your idea, understanding what is the impact and focus on the ideas that have the greatest chance of impact or can open up new ways of addressing a particular challenge. And in the U.S., it's a great climate for interest in manufacturing because of the geopolitical events and reflection on COVID. We all realize the importance of having robust, agile supply chains and developing advanced technology as part of the solution. And connecting additive to that story, I feel, is also very, very important. Because it's ultimately part of the big picture. Additive is only a way to achieve a new path for manufacturing, but there's many other pieces involved. And if I would say something is underappreciated, I feel it is the other pieces that are needed to bring additive forward in the process chain or in the organizational, and industrial ecosystem.
Very good point. Leads me to Lianghua. Lianghua, one question to you.
Yeah.
Would it be a solution to give a regional focus? I mean, Katrin, you just mentioned it. Sweden and Germany have a different regional focus. From a Chinese perspective, how is funding working there? Probably a quick remark on that. And would you consider everybody has a regional focus and we do like a worldwide research? What would be that? How is funding working in China?
Well, yeah. Regarding funding for AM in China, typically there are 3 application channels, similar like Xiong mentioned. Like we also have the federal agencies, state agencies. Another one, we have the another application channel from the private sectors. For the private sectors, usually they can via requested proposals like from listed companies, because there are many 3D printer suppliers. They might have specific request calls for some complicated questions, or they need some solutions for their 3D printer. So they will invite the researchers participating in innovation programs. We also have some opportunities to partner with cross-country collaborators, like our federal agencies. They have some resources to like partner with other countries like Israel, Pakistan, Australia, UK, Korea, etc. Yeah.
Very good.
So we might, we might collaborate through this kind of cross country partnership, programs. Yeah.
Thank you so much. The red clock is telling me we're already over the time, and I feel really sorry, I must admit, because having you here on the panel discussion and you online, we could discuss at least 2 or 3 hours about this topic, because so much to say. I summarized that we need some more support and funding, should be more open. I take Christian's point with me. We need certain applications so that you have a research focus, or gives you a research focus, and more international collaboration would be highly appreciated, at least by the 6th person joining us here in this panel discussion. Thank you so much for joining us. Thank you so much for the fruitful discussion. I wish you all the best, because you're really the foundation we need to foster the AM manufacturing industry. Thank you so much, guys and ladies. See you next time. It was a pleasure to have you. And we are going to the next point, where we go into the regions again and see what the different regions will bring us. Melinda will welcome you in a minute. And until then, see you. It was a pleasure having you. Thank you.
Thank you.